Hello students. Our today discussion is about periodic classification of elements and what are the blocks in the modern periodic table and what are the family names of all these elements in the modern periodic table. So everything we'll discuss in this video. First group elements are called as alkali metals, whereas second group elements are called as alkaline earth metals. Don't confuse, these are the old notations. Now they are replaced by the normal numbers only, group 1, group 2. Okay, in the old notations we have 1A, 2A, 1B, 2B like that, but now they are replaced by normal notations. First group elements and second group elements called as alkali metals and alkaline earth metals. Why they are called as like that? So alkali metal students, the reason is alkali means when a base dissolves in water is called as alkali. What is alkali? When a base dissolves in water called as alkali. So these elements are highly reactive metals. They form basic oxides which are highly basic in nature. So oxides, for example, sodium oxide Na2O, lithium oxide Li2O, all these are bases or not? And all these basic oxides, they dissolve in water and they form the respective hydroxides which are very strong bases. What is alkali? Base dissolves in water. These metallic oxides dissolve in water and they produce hydroxides or not, which are strong bases. That's why these group elements are called as alkali metals. Second group elements are called as alkaline earth metals. Don't confuse students, sir, why earth is added? Are they coming from earth? Remaining elements, where the remaining elements are coming from? They are also coming from earth only. Just to give the difference between alkali metals and second group elements, just the term earth is added, that's it students. So both the names indicate they have basic behavior. They are bases. Got the clarity? Next, directly 15th group is given. 13th group elements are called as boron family. They starts with boron. 14th group elements are called as carbon family. Why? Because they starts with carbon. Now 15th group elements are called as nicogens. Nico means unable to breathe, suffocating gases. These group elements forms the gases which are so suffocating, like ammonia gas. Yes, students, ammonia gas is unable to breathe, only ammonia. So ammonia, phosphine, even arsenic is also poisonous element in this group. So that makes this group, the name nicogens. Nico means unbreathable gases. Next, 16th group elements are called as chalcogens. Chalcogens means, calc means copper students, gen means generators. Like how 16th group elements can generate copper? Like is there any like a nuclear reaction? No. Copper in the nature is available in combination with oxygen, sulfur, very rarely selenium and tellurium also. All these elements, oxygen, sulfur, selenium, tellurium, all these elements belongs to which group? 16th group. That means if you want to extract copper, if you want to refine copper, we are refining copper from which group elements? 16th group elements. That's how they are generating, not by any nuclear reactions or not by any other thing. Understood students? Copper is removed from these group elements. That's why they are copper generators during the metallurgical process. Not only copper, majority of the elements are also available in their oxide form only. Next, 17th group elements are called as halogens. Halo means sea salt, gen means generators. That means these group elements, when they combine with metals or active metals, they form the salts. Salt is not a chemical name, salt is a family name. So what we know about salt is sodium chloride, not only sodium chloride, magnesium chloride also salt, potassium chloride, all these are salts only students. And what is the common element in all these salts? 17th group elements. That's why these group elements are called as halogens. Next we have some elements are classified as metalloids, right? Elements which have similar properties like metals and non-metals. Similar properties in the sense like they have both acidic behavior and basic behavior. So these type of elements, they are called as metalloids. For example, elements like boron, silicon, germanium, arsenic, antimony, tellurium and polonium. Polonium is radioactive. So this line of elements which separates metals and non-metals, they are called as metalloids. And the elements from the groups 1A to the 7th A, that means from the groups 1, 2, 13, 14, 15, 16 and 17, they are called as representative elements, which we already discussed about this point, except noble gases. Representative elements means main elements, like majority elements are representative elements. Majority means not by number, like major chemical compounds, major gases, major elements, what we are all the life is made up of, everything. Next, 18th group elements, students, they are called as zero group elements or inert gases. What are the elements in the 18th group? Helium, neon, argon, krypton, xenon and radon. Last element OG, oganesson, also 118th element. Radioactive, even radon is also radioactive. So these elements are called as noble gases. What's the meaning of noble? Noble means peace, calm, yes or no? What is the peace and calm related to the elements? These elements are chemically calm, chemically peace, which means they are chemically unreactive. These elements are chemically unreactive, that's why they are called as noble gases. Why they are unreactive? Why? Because they have completely filled electronic configurations, yes or no? For example, helium, what is the configuration? 1s2 completely filled or not? Neon 2s2 2p6 completely filled. Argon 3s2 3p6, 4s2 4p6, 5s2 5p6, all are completely filled configuration. That makes these elements, unreactive gases. They are also called as inert gases. Inert meaning also same. They are also called as zero group elements because their valency is 0. They are also called as inactive gases, rare gases. They are also called as aerogens. Different names are there. Aerogens means all they form air. All are gases now. Gases form air. That's why aerogens. So these are all the names. The elements in the group 3b to 2b, that is from groups 3 to 12. Follow group 3 to 12. They are called as D block elements. So where these elements are present, students? From group 3, from group 12. From 3 to 12, which elements are starting? Which D block elements are starting? Yes or no? They are called as transition elements. You know the reason why they are called as transition elements? What's the meaning of transition? Transition means something is changing. Something is changing. So what is changing? You know what is changing? In the periodic table, extreme left side, there are highly reactive metals are there. Extreme right side, there are highly reactive non-metals are there. Yes or no? That means in the periodic table, what is changing? What is the trend changing in the elements? Elements are changing from metallic to the non-metallic. Yes or no? And how they are changing? They are changing through these D block elements or not. Of course, D block elements are also metals only, but they are not active metals. They are not highly reactive metals. Got the clarity? Metallic nature decreases. What is changing? Element character is changing from metallic to the non-metallic. Then why these are called as? Why? Because this change is happening through this D block. So D block is like, it like acts like a bridge between S block and P block. That's why these group elements, these block elements are called as, students, transition metals or transition elements. That's it. That's the only reason. Next, elements of 1b like copper, silver and gold. They are called as, they are used to make coins, so they are called as coinage metals, right? These are all the highly lustrous metals, so least reactive metals used to make coins. This is also main point. These metals are called as coinage metals, and two rows are placed at the bottom of the periodic table, that is lanthanides and actinides are also considered to be the part of group the part 3b, which is group 3. These are usually called as inner transition elements, lanthanides and actinides. This point is very important, students. If you can see the modern periodic table, students, in the periodic table there are some elements which are placed at the bottom of the periodic table. They are called as lanthanides and actinides. Mostly they comes under F block elements. Why they are called as, first of all, why they are placed at the bottom of the periodic table? What happens if they include? We'll discuss in the next slide. Why they are called as lanthanides and actinides? Why? Because 4F elements we already discussed. When 4F will start after 6S. 4F elements will start after following lanthanum, so called as lanthanides. 5F element starts after actinum, so called as actinides. Ultimately, they are also called as inner transition elements. If you want to include them in the main periodic table, they were placed just before the transition element. So that's why they are inner to the transition, but they are called as inner transition elements. Are they placed in the periodic table, main part of the periodic table? No, they are placed at the bottom. Why? We'll discuss in the coming slide. Students got the clarity about actinides and about lanthanides and actinides also. Next, classification of elements into blocks. The whole periodic table is classified into 4 blocks: S block elements, P block elements, D block elements and F block elements. I am talking about this F block. If you want to place this F block, where we need to place F block elements, students? Here. Yes or no? After 6S, F block will start. If you want to place this F block here, how the periodic table looks like? It looks like more extended version. Yes or no? If it extends, does it look so good? No. It's not about looking good or not. There is one more reason. If this F block elements are placed, again group numbers will change. Yes or no? Now 1, 2, here 14 elements are there. We have new 14 groups and all these group numbers will also change. Got the clarity? And one more thing, to study about these F block elements in a separate group also no need. Why? Because almost all these elements are radioactive, which we can't find their chemical behavior. as well as they show almost same behavior only, because they have the valency shell is different and the last filled configurations are different for this F block elements, not only for F block, even for D block also. So that's why no need to give a separate space in the modern periodic table. Simply they are placed at the bottom of the periodic table to avoid all these disturbances, again group number changes, everything. So they simply placed at the bottom of the periodic table. So what is S block, P block, D block and F block? S block elements 1 and 2. On what basis they are classified? You know, on what basis they are classified? All these blocks. All these blocks are classified based on where the last electron is entering into, in which subshell. If the last electron enter into the S subshell, called as S block. If the last electron enter into the D block, D subshell, called as D block. If the last electron is there in the P subshell, P block, F subshell, F block. Let's find few examples. Let's take magnesium. What is the magnesium configuration, students? 3s2. Where is the last electron present in which subshell? S. So S block. Which comes at which how many groups are there? First group and second group. Yes or no? Next, 13 to 18, all P block elements. Why they are called as P block elements? Let us take any element. Oxygen. What is the configuration? 2s2, 2p4 is the configuration. Where is the last electron present? 2p4. Yes or no? The last electron is present in the P subshell. So P block. And as well as if you take any chlorine, what is the configuration? 3s2, 3p5. The last electron is present in the P subshell or not? Let's take boron, 2s2, 2p1. So all these elements, the last electron present in the P subshell, so called as P block elements. There is one exception, which is helium. Helium is an S block element, students. It is an S block element, but it is placed in the P block. Why? Because what is helium configuration? Helium configuration is 1s2. Where is the last electron present? S subshell. But still, why it is placed in the P block? You know why it is placed in the P block? Because it resembles its chemical properties with the 18th group. Why? Because it has a completely filled electronic configuration and there is no P subshell in the first shell. That's why helium is an exception in the P block. It belongs to here, but it is placed here because of its chemical resemblance with the noble gases, which is chemically unreactive. Got the clarity about all these blocks, students, based on last electron. Look at scandium. Scandium, atomic number 21. What is the configuration? 4s2, 3d1. Where is the last electron? Last electron means not valency shell. In the valency shell means it is S. Is it S block element? No. Last entering electron you have to check. Where is after filling 4s2 only, now we are entering into 3d. You have to check that. Last entering electron. That is also called as differentiating electron. So D block element, students. Next, we have certain S block, P block, D block. We'll discuss all the main points. So the differentiating electron means what? Last entering electrons enter into the S subshell, called as S block. It contains elements of groups 1 and 2. Two groups are there, students. Group 1 alkali metals, group 2 alkaline earth metals. So what are the elements of group 1 which comes under S block? Hydrogen to francium. Hydrogen is not alkali metal, remember. Alkali metal starts from lithium only. Hydrogen is a non-metal, but it belongs to the group 1. What is the general configuration? The general configuration is NS1. Yes or no? NS1 means what? What is hydrogen's configuration? 1s1. Lithium configuration? 2s1, 3s1, 4s1, 5s1, 6s1. So what is the common thing in all these elements? S1, 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 S1. All have in NS1. In general, NS1. N means any period number. You can write 2, 3, 4, 5, 1. 1s1, 2s1, 3s1. S or no? N means the number of shell, the last shell, valence shell. Next, alkaline earth metals general configuration is NS2. Why? Because 2s2, 3s2, 4s2, 5s2, 6s2 all have s2 configurations or not. So in general, NS2. Alkali metals, alkaline earth metals comes under this S block. Next, P block. Which elements are called as P block? Answer directly. The last entering electron, so it's not the valency. Some might be S block and P block. The valence shell is also same differentiating electrons, but it is not same for D block and F block. Okay, remember that. So if the last electron entering into the in the P subshell, called as P block, and look at the main points under the P block. What are the groups which comes under P block? From group 13 to group 18, boron, carbon family, nicogens, chalcogens, halogens and noble gases comes under P block elements. Except helium, we already discussed about helium exception, students, because its chemical resemblance with P block. Here noble gases, chemical resemblance with noble gases, it doesn't have P subshell. So that's why it is an exception. So what is the general configuration? The general configuration is NS2 NP126. NS2 means any in general 2s2, 3s2, 4s2. NP126 means where the group ranging from 13 to 18. What are the elements configuration ranging from? P1 to P6 configuration, yes or no? P1, P2, P3, P4, P5, P6. So all these 13 to 18, that is a general configuration, students. Next, this includes metals, non-metals, metalloids and inert gases. P block elements contains metals, non-metals, metalloids and inert gases. Also, students, all are elements. Why? Because left to right metallic character decreases, top to bottom metallic character increases. That's why lead, all these elements are, all these metals are there in the P block only. So next, so the elements of S block and P block except are called as representative elements. We already discussed about this point about the representative elements. Next, D block elements. So what are D block elements? The elements in which the last electrons enter in the D subshell of the penultimate energy level. Shells are also called as energy level. What is this penultimate? Last shell is called as valence shell. The shell before the last shell is called as penultimate shell. Where the D block elements will start, students? D block elements will start from 3D. When 3D will come? After 4s only. Yes or no? 3D is entering after filling. For last valence shell is 4s. But are we creating these blocks on the valence shell? No. Last entering electron is in 3D. 3D orbital is called as penultimate shell, which is last but one shell. Okay. So and this block is situated between S block and P block. It contains all these groups from 3 to 12. Total 10 groups are there under D block elements. What is the general configuration? N-1 D 1 to 10 and NS 1 to 2. So what is the meaning of this general configuration? NS 1 to 2, N-1 D 1 to 10. Why? Because, students, if you want to write the configuration of 3D, when 3D will start? After 4s. The valence shell is not 3, students, the valence shell is 4s. So NS means 4s. N-1 means 4 minus 1 or not. Then you will get 3D or not. That's why N-1. 1 to 10 means 10 blocks are there. So that's why 1 to 2 means there are some exceptions like chromium, copper configurations because of electron excitations. So it is NS 1 to 2, students. So for example, if it is 4D element, when 4D will start? After 5s. When 5D will start? After 6s. When 6D will start? After 7s. That means it is always one shell less than the valence shell or not. That's why N-1. Right. Next, D block elements are further classified into series, 3D series elements, 4D series elements, 5D, 6D. Yes or no? The total 4 series elements are there, and each series the elements are also given. That's all about D block elements. Electronic configurations are also given. So next, F block elements. F block elements. What are F block elements? Which are placed at the bottom of the periodic table. 4F and 5F, they belong to the third group. They belong to the 6th and 7th period, students. Lanthanides, actinides. 4F elements are called as lanthanides. 5F elements are called as actinides. So where they are entering into the elements in which the last electrons enter in the F subshell of the anti-penultimate shell. You already know penultimate. What is this anti-penultimate? Last shell, valence shell. Last before is penultimate. And before this penultimate is anti-penultimate shell, students. That means last but two shell is called as penultimate shell. Yes or no? Simply, when 4F will start? When 4F will start? 4F will start after 6s. Got the clarity? 4F will start after 6s. That's why you can see the general configuration also. It is NS2, N-1 D 0 to 1 as well as N-2 F 1 to 14. Why N-2 here? Why? Because the last entering electron is entering into the last but two shell. That is called as anti-penultimate shell. That's why N-2. And N-1 D 0 to 1. Why? Because of the energy changes, some elements, electrons also can enter into the D orbitals also, which is in the penultimate shell. So these are all about the F block element, the general configuration. Why they are called as lanthanides? They follow after lanthanum. Actinides, they follow after actinium. Ultimately, they are called as 4F elements and 5F elements. Why they are not placed in the modern periodic table also? We discussed this point also. Now, what are the main points here? The last shell is called as valence shell. Last but one shell is called as penultimate shell. Last but two is called as an anti-penultimate shell. That's it, students. Periodic table is very important chapter, students. Periodic classification of elements. We discussed all the early classifications, Mendeleev periodic table, modern periodic table, and how these elements are classified into blocks and what are the importance of each and every block and the family names, everything. All the main points are there. And modern periodic table is the ultimate classification, students. So that's all for today in this video, and the remaining concepts we'll discuss in the next video. Thank you, students.